So we wrote our first slightly more useful program and we got started with variables, values, types, and operators. Now, as you can see, this formula here is rather long. Well, I guess it could be more complex, but it is rather long because we have these type conversions in here, because Go doesn't allow us to mix different types. Even though we're just dealing with numbers here, as you saw, for Go, numbers are not necessarily of the same type. Instead, we have integers and floats. And by the way, that's something you'll see in other programming languages as well. That's why we had to convert these integers. But of course, the conversions here unnecessarily bloat our calculation. So is there something else we could do? Yes, there is. If we know that we need to use these values, the investment amount and the years, in calculations that want floats, we can tell Go that these values should be stored as floats in these variables to begin with. Because what Go does here for investment amount is that it infers the type of value that is stored in that variable. It simply takes a look at that value and sees that this here, the 1000, is a value without a decimal place, and therefore it infers that it should be of type int. And it creates a variable of type int, therefore. But of course, this would be a problem if we would have an expected return rate of 5. Now it's also assumed to be an int, because this number has no decimal place, but of course the return rate should be able to accept all kinds of values where only some values are without decimal places. Most values will have one. So the inferred type is not always the type you want. Thankfully, you can override Go's inferred value though. You can add an explicit type annotation, a type assignment here, after the variable name. For example here, we could add float 64, which is one of the built-in types Go supports. You see all basic built-in types here, and we'll see some of them throughout the course. Float 64 is one of them. When assigning a type explicitly like this, you override the inferred value, as you see here. And you can still store a number that does not have a decimal place, as you see here, but internally, by Go, it will be stored and treated differently. And we can do the same here for the years, and also set this to float 64. And when doing that, since those numbers now will be stored and treated differently internally, we can get rid of these type conversions down here, because now we're already dealing with float 64 values, and we can therefore shorten this formula. Now it's much more readable, I'd argue. And with that, if we save this, and we open our terminal, we can again run this program, and of course we get the same result as before, but now we don't have to deal with these type conversions. Now of course that will not always be an option though. Sometimes you might have a number that's an integer that should be used as an integer in some calculations and as a float in other calculations. And in such cases, you'll need to do some type conversions. But here, where we only use these numbers in this one formula, which wants floats, we can simply explicitly set our types of values.